2.2 graphing polynomials. Perfection, do you need paper? Here, I've got it.
Thank you.
I'll come around and look at it. All right, 2.2, day 2, or just day 1, graphing polynomials. All right, so just some little steps to get you rolling here. Because it's going to be so fun. Okay. Please write down f of x equals x to the 4th minus 4x squared. And then go ahead and determine the highest degree, the leading coefficient, the end behavior, the possible zeros, and the terms. Now it's time to factor. They have a GCF. Yeah, let's factor out x squared out of both of these. All right, so we factored out x squared, but are we done factoring? What's this? That's right, good job. So when I write this in fully complete factored form, this is what it's going to look like. Now remember, I asked you to go find those words, tangent, straight, and change in concavity, because all of that stuff applies to this. So you factored it. That's an x-intercept. That's going to be an x-intercept at positive 2. That's going to be an x-intercept at negative 2. But when they get to the x-axis, they do weird stuff. But there's only 3 things they could possibly do. And it's that stuff from yesterday. So when we cross the x-axis, it's either going to go straight through like a plain boring line, or it's going to bounce off of it, or the x-intercept's going to be crazy having a party with the change in concavity. And it's so easy to tell what they do. If the x-intercept has an exponent of 1, it's boring straight through. If the x-intercept has a repeat of any even number, it's going to bounce. It's going to be tangent. If any x-intercept has any odd, it's going to be swirling, and it's going to be a change of concavity. All right, here we go. So when we go to plot this stuff, we're really focused on the x-axis. So make your x-axis really long. Y-axis, not so much. All right, so we have a x-intercept, and I'm going to color code these for the first time. We have an x-intercept at 0. But look, this x-intercept repeats. It has an exponent of 2. So it's going to bounce off the x-axis. You have to write the letter T for tangent if you want full credit. I am not showing anything extra on this stuff. Your graphs have to look just like mine for full credit. All right, so it crosses the x-axis there. Remember, it also crosses the x-axis at positive 2. Look, you have to write the 2. Y'all didn't have to write 0. I know that's 0. We all know that's 0. But regular numbers, you have to write it underneath. All right, that's an x-intercept. And this has an exponent of 1. So we're going to write S because it goes straight through. I know that's a weird looking S, but I make them weird on purpose because I don't want anybody to confuse it with a number 5. So my S's look like that. All right, your last x-intercept is going to be over there to the left of the origin at -2. So remember, that was +2, -2. You got to write the -2. It's to the degree of 1. This little x-intercept is to the first power, so straight through. All right, end behavior. So we already decided the end behavior was up, up. So after I plot these x-intercepts, I draw the end behavior because I have to match the arrows. So it is up, up. After you plot the x-intercepts, draw the arrows. All right, so now you just got to fill in the gaps. It's kind of like it is connecting the dots. All right, so remember this goes up, so it's going to come down. It has to pass straight through. So it goes straight through. So now it's below the origin, but it doesn't go down forever. It has to turn and touch this x-intercept. And remember, it's tangent, so it's going to bounce off of it. The graph is going to stay below the origin. Never cross when it's tangent. So it's still below the origin. It bounces back down. But it's got to turn because you have another x-intercept. And remember, it was straight through. And then you just connect that up with your arrow, and you are good to go. That's graphing polynomials. I'm going to do it one more time, and then we'll stop and see if you guys have any questions. So here's example 2. -4x to the third plus 4x squared plus 15x equals f of x. All right, guys. The highest degree. Is the highest degree even or odd? Odd, that means what kind of end behavior? Opposite. That's how quick you guys have to rattle that stuff off. Is your graph going to be up or down on the right? Down. There you go. So we know that shape is going to look like this. All right. Factor time. By the way, I need to make sure I have zeros in the amount of 3. I've got to count up 3 zeros. I know for sure I'm factoring out one thing for certain. What do you have to factor out? The negative. Great job. Is there a GCF on this stuff?
X.
There is an X. Y'all, I apologize to you. I said the X, but I didn't write it. Make sure you have an X here. -4x to the third plus 4x squared plus 15x. Yes, they all have an X. So let's factor out the negative and factor out the X that they all have. Remember, when you factor that out, the signs change. So this is going to be positive 4x squared minus 4x minus 15. We need to check to see if that trinomial is factorable. So I'm going to go over here, draw my little graphic organizer. 4 times -15 is going to go at the bottom. That middle term's at the top. Who's got it? What are those magic numbers? What multiplies down to a -60 but adds up to a -4? 6 and 10. Good job. So 6 and 10 are the magic numbers. We're going to make 10 negative. All right, guys, don't forget to divide by that 4. Okay, neither one of those simplify to a whole number, but they both simplify as a fraction. So this simplifies to 3/2. This one simplifies to -5/2. I'll just put it right here. Okay, so when we factor this out correctly, -x, still brought down from my GCF, just brought it to my next line. then this is going to be 2x plus 3, and then 2x minus 5. All right, let's draw a really long x-axis and graph this. Zeros. We have 3 zeros. Our first 0 is right here at the origin. That single x we took out is to the first degree. It's straight through. The next x-intercept, this 2x plus 3, that's going to be negative 3/2, which is going to be the opposite of this. This is negative 3/2, always the opposite of that. Negative 3/2 looks good right here, and y'all can leave it as an improper fraction. It's fine. This was to the first power, so it's straight through. 2x minus 5 is going to turn into a positive 5/2. Make sure you draw a dot to the right of the origin. This little factor is to the first power, so it's straight through. And then, again, I suggest you draw those arrows because it frames it. It makes it all pretty easy to get started. All right, so arrows up on the left, down on the right. All right, so we're going to cross. All of these are straight through.